Triangle ABC in which altitude BE and CF to side AC and AB are equal. Okay. Show that triangle ABE is congruent to ACF. Okay. And AB is equal to AC, and thus ABC is an isosceles triangle. Again, write what is given, what is to be proved, things which can be implied from what is given, all that you need to write, and then unpause. Okay, so I hope all that has been done. We have been given that ABC is a triangle in which altitude. So BF and CF are altitude to sides and they are equal as well. So we have BE is equal to CF. Then what else can we, okay. Then we can also write that BE is perpendicular to AC. This implies angle BEA is equal to 90 degree. And also we have, just a second. And also we have CF is perpendicular to AB, which implies angle CFA is 90 degree. Then what else? That's it. Yes. So we need to prove that triangle ABE is congruent to triangle ACF. Actually, if you prove this, we can prove AB is equal to AC. Right? CPCT will be done. Okay. Now think about how to prove. So we have a scenario wherein triangles are overlapping. The best way to handle this is draw a separate small diagram. So we have ABE and ACF. So it's very clear this is 90, 90, angle A. Then is common, right? In both of them, angle A is common. Then we also have that these two lengths are equal. And if we happen to prove this particular angle B and this particular angle C are equal, by ASA we are done. Okay. So first thing is somehow we have to get an expression of angle B in terms of A and E and angle C in terms of A and F, because E and F are 90 degree. Remember, they are equal. Okay. So always try to draw a small diagram. Okay, not that small, but medium sized diagram in the middle of the paper, and yes, that's part of your answer, not an issue. So first we'll get an expression for angle B in triangle ABE. So we have angle A plus angle AEB plus angle ABE, which is equal to 180 degree. So this is as per angle sum. Property of triangle. So this happens to be 90 degree, and so we have the expression angle ABE is equal to 90 minus angle A. Okay, by transposing all of this, we'll get this expression, right? And similarly in triangle AFC, we have angle A plus angle AFC plus angle ACF, which is equal to 180, but this particular angle is 90, and by transposing ACF will be equal to 90 minus angle A. We'll call this as equation 2 and 1, right? So with this 2, we can clearly tell these two triangles are congruent. Now we'll tell in triangles ABE and triangle ACF. We have angle AEB, which is equal to angle AFC. Both of them are equal to 90, and we have the altitudes which are equal. This has been given, and we have the third one, angle ACF is equal to angle ABE. This is from 1 and 2. And with this information, set of information, you can tell by ASA congruency triangle ABE is congruent to triangle ACF. Okay, so that is your first part, I guess. ABE. Yes, that's correct. Then we have to prove that AB is equal to AC. That's quite simple by CPCT. By CPCT, AB is equal to AC. Hence proved. Okay. So again, the key over here is always writing what is given properly and implying whatever you can infer from such information. And then a diagram. Sorry, to prove. So we proved both of this. List the things that you need to prove so that you can put a tick once you are done. And then diagram whenever things are overlapping. A rough diagram is good enough, but not too small. If you're able to draw a neater diagram, that's more helpful. Yeah, I would have done a better diagram on a sheet of paper. Here it's not so simple, with the digital things. Once you have an idea about how to prove, then try to write things systematically. Okay, and then conclude so that things are neat, clear, and a person looking at your paper understands what you're doing. So pause and have a look.